Okay, here's another way to prove that a squared plus b squared equals c squared. Another way to prove the Pythagorean theorem. So this large right triangle, see if I turn it this way, it's more obvious. It's a right triangle. Is divided up into two other right triangles, which I've copied and created here and here, and they're labeled the same way as you see, right? HH, part Y of C, part Y of C, part X of C, angle B, and here is also side A, and these are side B's, right? So I have all these triangles, and I'm going to try and solve this using proportions. So this triangle, if I set it like this, it's similar, right? Because all the angles are similar, it's scaled down. It's been shrunk down a little bit. So if I look for ratios like B is related to Y, as this B is related to all of side C, part X plus part Y. So I can write that relationship as B is to Y as, now B is the bigger triangle, so as part X plus Y, which is all of side C, is to B, right? That's a proportion. That's the first one. Now the second one is if I try the smaller triangle and I lay it on top, like so, I have, let's see, so this is a triangle like this, right? So it's this piece, but if I flip it over, that says part X of C. Here it just says X. So it's a little confusing, but let's try and make another proportion. Let's try and involve A because we're looking for A squared, B squared, and C squared. And here I have B. And these are parts of C, so that's helpful. So let's go and go with A. So the bigger triangle A is to part X as, well, here is X plus Y is related to A, right? This whole side is similar to side A. So X plus Y is similar to the small side A. So this is big side A, and this is small side A, right? So we have two proportions. Hopefully you get that. Now let's move on to understanding that I can cross multiply to create equations that don't involve fractions. So B times B is B squared equals Y times X plus Y. And then down here it's A squared equals X times X plus Y. Now, what I can do here is I can combine these two equations. Like if this said 3 equaled 2 plus 1, and this said 5 equaled 3 plus 2, I could combine all those parts, and it would be equivalent on either side. So I can just do A squared plus B squared equals Y times X plus Y plus X times X plus Y. Okay, now I have A squared plus B squared. That's part of the Pythagorean theorem. Now I need C squared. So let's see, what's the best way? I can factor out X plus Y, and then I'm left with Y plus X. Well, I can just rewrite that as X plus Y times X plus Y, which is equivalent to X plus Y squared. And wasn't the length X plus Y, wasn't that equivalent to side C, right? This is part X, this is part Y. So that's the same thing as C squared. So now I've proven that A squared plus B squared equals C squared. All right, I hope that helps make it clear.